Hello everyone. Are you all ready? Today we are going to deal with mainly conservative and non-conservative forces. Conservative and non-conservative forces. So let's discuss about the first one is called what? Conservative forces. What is meant by conservative force? So let's discuss first the definition. After that I'll giving the examples of that. A force is said to be conservative. Okay, a force is said to be conservative if work done by or against the force in moving a body depends only on what is that depends only on the initial and final positions of the body. Initial and final positions of the body. Okay, and not on the nature of the path followed, and not on the nature of path followed. So this is the definition for conservative forces. Let me read once again. A force is said to be conservative if work done by or against the force in moving a body depends only on the initial and final positions of the body and not on the nature of the path followed. So maybe you didn't get the clear idea about it. So let me give one example here. The conservative forces, the examples for conservative forces. The first one is the gravitational force. Gravitational force is an example for which one? Conservative forces. We will discuss in detail. The next one is the elastic force. What is that? Elastic force is also an example for a conservative force. Elastic force means what? Maybe in a stretched or compressed spring. Elastic force in stretched or compressed spring. Another one is called, the third one is called electrostatic force. Electrostatic force. What is meant by electrostatic force? Electrostatic force means what? The force acting between what? The two charges. Okay. And one more is the, as an example, one more we can say that magnetic force. Magnetic force. These all are the example for the conservative forces. So now let's discuss in detail what is meant by conservative forces. If work done by or against the force in moving a body depends only on the initial and final position of the body and not on the nature of the path followed. So let me give one simple example here. This is the case. Just imagine a body is on the surface. Okay, this is a body which is on the surface. Now we are going to raise this object. Okay, we are going to raise this object. So we are raising this object means we have to apply a force. An external force must be applied. So this is the case. I am raising this object and the body is now at present now at the particular height. The height is given the side as h from the surface. Now how much work has done here in this case? You have applied a force on the body, that is the external force. but there is a force acting which is downward, that is called what? Mg, that is force due to gravity is acting Mg downward. Now what is the displacement direction? The displacement direction is again upward. You are raising this body, displacement is upward, but the force due to gravity is acting vertically downward. In this case, what is the work done? What is the work done? We can say that definitely there is an energy stored is called what? Mgh, correct? The potential energy it is. So just imagine the work done is here, which is equal to mgh. Just imagine the work done is equal to mgh. This is same as the potential energy. Now the same example, now what I am going to do here, same body, okay, the same body which is on the surface. Now I am going to raise this object, not exactly straight. I am just going to shift this body like this, raise the body like this, and I slightly moved in this direction, and again I have moved a little bit raised, and again I have slightly moved in horizontally, and finally it comes to the position like this. See this one? It comes to the same position as in the first case. Okay, as in the first case, same height I have raised here, the same height h I have raised here, but the path which I have followed is different one. Path which followed is different one. In this case, how much work is done now? In this case, what is the work has done? Can you say what is the work done here? How much work is done in this case? How much work is done? Yes. So now type the answer, that is equal to mgh. What is the answer? The mgh. Very good. That means here the path followed, that means the path followed is different. Okay, maybe some little bit slightly above. Okay, is this sound is okay now? Okay, let me check it. Now is it okay, everyone? I think it is okay. Now is it okay, everyone? Okay. So what I have explained here, in the first case you have raised the body which is exactly a particular height h, and the work done is equal to, we can write it as mgh. In the second case, as a second example, what I have done here, same body have raised the same height but in different path. So I have asked here how much work is done to raise this body. Again someone has given the answer, the work is same as mgh. Even though it is go through different path, okay, but it is raised to same height, So here the work done is also equal to what? Same. Now look back to the definition once again. If work done by mean the applied force or against the force mean force due to gravity in moving a body depends only on which all points? Initial and final position. You see in the both the example, the initial position as well as the final position both are same. So work done is also equal to what? Same only. Correct? It doesn't depends upon the nature of the path followed. That means this is an example for what? Conservative forces. So which are the example we have discussed here? Gravitational force is an example for conservative forces. Elastic force, electrostatic force, magnetostatic force, or simply magnetic force. These all are the example for what? Conservative forces. Till now, is it okay with you all? Okay. Now let me give one more characteristics of the conservative forces. Okay. Same example we'll discuss here. Same example. Okay. This is the surface. A body is now placed here. Okay. A body is now placed. Just imagine the body is now raised. Body is now raised to a particular height. Say it as the height is h. Same example we are discussing. An object is raised with a particular height h, and again the same body you are bringing it back also. You are bringing it back also. So what is the work done against the force, against the gravitational force? So here we can say here, when it is taking up, the negative work done is done. The negative work is done. Why? mg is acting vertically downward. Example, when you are raising this object upward, okay, when you are raising this object upward, the mg force is acting vertically downward. Mg is acting vertically downward when you are raising. Displacement is also upward. So if you use the work done formula, W is equal to F dot S. W is equal to F dot S. So we are applying the force. Abhishek, we are applying the force here. Then only the body will go up, right? We are applying the force means that is the external force. Now we are talking about the force due to gravity. Okay. So W can be written as Fs cos theta. W is equal to Fs cos theta. Here how much work has to apply to move this body? Same as mg. Same as mg. So I can write here W is equal to mg. Displacement is S. What is the direction of displacement and mg? Tell me the answer. What is the angle between displacement and the mg? What is the angle between mg? Mg means the force due to gravity. Force due to gravity. What is the angle in between displacement and mg? Anyone know the answer? Very good. Arjun, 180 degree, right? So I can write here mgs, Sanam, it is not 0, 180. See this one? Mg acting vertically downward and displacement is acting upward. So it is 180 degree. Marek. So we can write here mgs cos 180 degree. So W is equal to, we can write their word, minus cos 180 is equal to minus 1, right? So minus mg, here displacement we have taken the entire displacement is equal to what? Height h. So I can write here what? Minus mgh. Minus mgh. So what I have explained here, when you are raising a body or an object upward, the work done is negative by who? By the gravitational force, not by the applied force. Okay, not by the applied force. Work done by the gravitational force is negative. I hope it is clear. Now just imagine the same body, it is coming back, bringing back here. When the body is coming back, mg will be acting in the same direction. Mg will be acting in the same direction. That means downward. Mg will be acting downward only. Now when the body is bringing it back with an external force, just imagine with an external force, what is the displacement direction? Displacement is also acting in opposite direction. I mean the same direction of mg. Displacement will be also acting in the same direction of mg while it is coming back. Correct? So in that case, what is the work done once again? W is equal to Fs cos theta. In this case, what is a theta? If anyone know the answer, when the body is coming back or bringing back, displacement as well as the mg both are acting in the same direction. Correct? So what is the angle between the force of gravity? We are not talking about the external force, we are talking about the force due to gravity, mg. What is the angle between mg and the displacement? Yes, very good. So answer is equal to 0. So we can write here what? W is equal to Fs cos 0. Cos 0 is equal to what? 1. Very good. So W we can write it as mg into S, or W is equal to mg into h. The displacement is equal to h, right? So what we have proved here, while you are taking the body up, the work done by the force of gravity is equal to minus mgh, correct? Now while you are taking the body back to the original position, the work done is equal to plus mgh. Okay, so another important point we are discussing here. So what is the net work done? What is the net work done during the round trip? During the round trip, what is the net work done? Can anyone say the answer? What is the net work done during the entire trip? What is the net work done during the entire trip? Round trip means it's coming back, cyclic. Starting from one point is again coming back to the same position. So what is the net work done during the round trip? We can say that what the answer is equal to, right, the answer is equal to 0. The entire work done, we can see here minus mgh and plus mgh. So net work done W is equal to 0. Very good. So these are the another characteristics of which force? Conservative forces. Okay. So what is meant by conservative forces we have discussed now? Which are the 2 points we have discussed? One is the net work done during the round trip is equal to 0. Another one, it only depends on initial and final position, and these are the two main characteristics of what? Conservative forces. I hope it is clear what is meant by conservative forces, which are the examples of conservative forces. Now, let's move to the next one, that is the non-conservative forces. Okay, non-conservative forces. What is meant by non-conservative force? That's what next one we are going to discuss about. Okay, non-conservative force mean, if what is the definition we can write here first? If work done by or against, work done by or against the force, in moving a body, same definition starting, in moving a body, depends upon the path between the initial and final position. Depends upon the path between initial and final position. Okay, so what is the first one we are discussing? Conservative forces. The work done by or against the force in moving a body doesn't depends upon the path between the initial and final position, right? But non-conservative force means what? It depends on the path between the initial and final position. A simple example, you see this one, this is a surface, okay, this is a surface. A body is now moving. Just imagine this is a rough surface. A body is moving in this direction. You are applying this force here. After some time, just imagine the body is reached here. After some time, the body is reached here. Okay, this is the initial position and this is the final position. How much work has done here? We can say that the work has done against the force of friction, because applied force is you are doing against the force of friction. So you have done some work. Okay. Now in another example, same body starting from the same point, but the body is now dragging in different path. I cannot draw the path directly. Just imagine it is going in different path and again come back to the final position, the same position as before. My question is here, is the work done in both case is same or different? In the first case, it was going straight and the work done against the friction is done. Now second case, the same body is moving from the same position and but in different path it is following. You just imagine you are dragging some object, a desk or a bench, whatever it is, you are dragging. Is the work done is same as the first case? Is the work done is same as the first case? Very good. Definitely it will be different value. It will be different value. So what we are concluding from here, this type of force, mainly the frictional force, is an example for non-conservative forces. Okay, so one of the important example for non-conservative force is what? Friction, because the frictional force depends on what? The nature of the path, or the work done by the frictional force depends upon the nature of the path. Now again you just imagine you are bringing this body back to the original position. During the entire cycle, we cannot say that the net work done is equal to 0. The net work done is not equal to 0. So this is an example for what? Non-conservative forces. Is it okay with you all? So what is meant by non-conservative forces? It depends upon the initial and final position. Okay, that is the non-conservative force. One of the example is here what? Frictional force. Okay. Now maybe you can note it down. What is the main difference? Okay, what is the main difference between conservative force and non-conservative force? What is the main difference between conservative force and non-conservative force? Note it down. Just differentiate. Conservative and non-conservative. Conservative and non-conservative. What is the difference between? First point you can note it down. Here in conservative force, the work done does not depends on path followed. Work done does not depends upon the path followed. In non-conservative force mode, the work done depends upon the path. It depends upon the path. Okay. Second important point, work done in a round trip. Work done in a round trip is 0. Work done in a round trip is 0. In this case, we can say that what? It is not 0. It is not 0. Okay. Third point, conservative forces are central in nature. That is, it is central forces. Central in nature. Where non-conservative forces, it is velocity dependent. Velocity dependent and retarding in nature. And retarding in nature. This is the next differentiation. Next point is that what? work done. Next one, the last one, we can note it down here. When conservative force is acting within a system, okay, when a conservative force is acting, the mechanical energy does not change. Their sum means what? Mechanical energy. Their sum means the mechanical energy does not change. Does not change. But in non-conservative forces, what we can say that some energy dissipated as dissipated as means what? Wasted, right? As what? Heat energy. It is dissipated as heat energy. So these are the main difference between conservative and non-conservative force. Okay, conservative and non-conservative force. I hope it is clear for everyone. There was some slightly disturbances. Next class onwards I will be making it correct. Okay, so today we will be winding up only conservative and non-conservative forces. We'll be discussing the next topic is the potential energy.